Let's look at maximum error and standard error in this video. Maximum error is denoted as E. Maximum error is denoted as E. Why standard error? Why standard error is denoted as delta. Now, this topic, maximum error and standard error, both fall under rules for combining errors. Now, take note that we have different formula for calculating maximum error and standard error, and the formula depend on the type of formula you are being given. Now, let's see different ways in which we can write the formula for maximum error and standard error. Just pay attention. Now, I'll be dealing with maximum error here. Maximum error here. Maximum error E. Now, remember I said something that for you to know how you are going to write the maximum error, it depends on the formula you are being given. Now, if a formula involves addition and subtraction, you have a formula that involves addition and subtraction. If your formula involves addition and subtraction, for example, if I have Z to be equal to A plus B minus C. Now, take note that you will be given in the question, you'll be given the value of A and the error in A. You'll be given the value of B and the error in B. Also in the question, you'll be given the value of C and the error in C. Now, when you have been given all these parameters, how do we get the error in Z? Now, take note of something. Take note of the fact that to get the error in Z, what type of error? Maximum error in Z. We are going to sum up the errors in each of them. Now, I'll say error in B plus error in A plus error in B. I know something will be tempting for you to say minus error in C, right? But take note of the fact, we don't subtract errors, we add errors together. Even if your formula is Z equal minus A minus B minus C. For you to find the error in Z, you are going to add all these errors together. You are going to add all the errors together. We don't subtract errors, but we add all errors together. Take note of that. So when you are being given the error in A, error in B, and error in C, for you to get the error in Z, what you do? You sum up all the errors, and that's how you have it. Now, if your formula is involving multiplication and division, how will you do it? Let me say you have Z equal A times B over C. How will you write your formula? Remember, you'll be given the value of A and the error in A. You'll be given the value of B and the error in B. Also, you'll be given the value of C and the error in C. Now, how will you now get the error in Z whenever your formula involves multiplication and division? It's very simple. Look at the pattern you are going to write this one. EZ over Z equal EA over A plus EB over B, similarly plus EC over C. Now, for me to find EZ, what will I do? EZ equal to Z, if you bring this on, multiply everything by Z. We now have EA over A plus EB over B plus EC over C. Now, this is how to calculate the maximum error in Z whenever your formula involves multiplication and division. Take note of this, very, very vital. And lastly, when your formula involves exponents, that is, if it involves power, for example, if I have Z to be equal to A to the power of n times B to the power of n over C to the power of what? To the power of, let me say, K. Now, remember, you'll be given the value of A and the error in A, the value of B and error in B, the value of C and error in C. Now, how do you now find the maximum error in Z? When you are finding maximum error, you are going to say EZ over Z. It will still follow this same pattern, but the rule is that drop down the power and make it as coefficient of all these. That is, remember, I'll say EA over A. Now, what is the power I'm having here? M. You write it here like this. Plus EB over B. What power I'm having here? N. You write it like this. plus EC over C. What's the power I'm having here? K. Please don't say divided by EC over C. Add everything together like this. Then also you have EZ equals Z multiplying MEA over A plus NEB over B plus KEC over C. Then that is how to write maximum error formula. So whenever you are having addition, you use this, or subtraction, you use this, multiplication and division, you use this. Then, multiplication and division, you use this formula. Then exponent, you are going to use this formula. Do not forget that. Okay, we are done with maximum error. Now let's look at standard error. Standard error, which is denoted as delta. Now, trick. Do you know that if you can know formula for maximum error, you don't have to stress yourself for standard error? Let's focus on this layman explanation. Square each term of your maximum error, you are going to get your standard error. Again, square each term in your maximum error formula, this, and this, then what you get is your standard error. Let's see if it's legit. And take note, square each term, and anywhere you see E, replace it as delta. So let's go. Look at this part now. Anywhere I see E, replace it as delta and square each of them. So I'll say delta Z square equal delta A square plus delta B square plus delta C square. You can see. Then for me to find my standard error in Z, I'll just square root both sides. And if I square root both sides, this square will cancel out. Then you have square root of delta A square plus delta B square plus delta C square. And that is it. I'm done with the first part, addition and subtraction. Next one, if you are having multiplication and division, something like this, what will you do? Let me write it somewhere here. What will you do? You are going to say, remember, I want to square each of the term. So let me write from here. From here, you will see I'll have delta, that is standard error, delta Z over Z all square equal to delta A over A all square plus delta B over B all square plus delta C over C all square. Remember that you are going to change E to delta, then square each of the term. Then for me to find, I can just say delta Z over Z equal square root of delta A over A square plus delta B over B square plus delta C over C square. As simple as this. And you can just multiply your Z here and you get your final answer. And that's the way we do each and every one of them. Also for this. Now, this one, let me write the standard error formula for exponents. What will I do? Permit me to erase this part. So just jot it down so you get the concept clear. So what will I do now? To get the standard error for exponents. So what will I do? Square each of these terms and put, so I'll say delta Z over Z equal, square equal M square delta A over A square. You can see the trick. Then N square delta B over B square. Then what again? Let me erase this part. Then K square delta C over C square. So I have delta Z over Z equal square root of M square delta A over A square plus N square delta B over B square plus K square delta C over C square. And that does it. Then you can now, maybe if you are looking for delta z, you can now multiply, but you can just leave everything this way. So this is how to write the standard error and the maximum error formula. Very, very simple. Now, jot all this down and let's see how we can apply this in question. Okay, now look at this. Let me say I have this formula. A equal x plus y minus b. See what I have. Now, let me now take for instance that you have x to be equal to 100 plus or minus 0.46 gram, and you have y to be equal to 512 plus or minus 0.8 gram, and b is equals to 412 plus or minus 10.0 gram. Now, I want you to find the standard error in A and also maximum error in A. So the question is find the standard error in A. Let me write it forward. Find the standard, let me write maximum error. Find the maximum error in A and find the standard error in A. Okay, so it means that all the concepts we've learned earlier, we are going to apply it. Now, if you observe, this formula just have to do with addition and subtraction. So the standard error, remember, for me to get the standard error in A, since I'm having addition and subtraction, I will add all the errors together. That is error in X plus error in Y plus error in B. Add everything together, regardless of this minus, add everything together. So let's go. What was my error in A now? It's now what's error in X? You see, whenever you are being given something like this, take note that a complete measurement always have value, standard of comparison, and uncertainty. And look at it here. Look at the real values here. The value of x is 100, the value of y is 512, and the value of b is 412. This is what you are. This is how you'll be given a complete measurement. Now, you see this gram, they are the standard of comparison. In other words, we call them units. And lastly, you see this 0.46, 0.8, 10.0, they are the what? Uncertainties. And those are the what? The error we have here. So the error in x is 0.46, the error in y is 0.8, and the error in b is 10.0. Take note, they are not the real value, they are the what? Error or the uncertainty. So let's go. So what's my error in x? 0.46. What's my error in y? 0.8. What's my error in b? 10.0. So this, I'll add everything here together. And what will I have? So 0.46, 0.8, 10.0. That will give me 11.3 gram. And that is it. Now, there's something I want to tell you. This is the error in A, the maximum error in A, and we are done. And do you know that it's possible for me to write A in this aspect also? How will I do it? It's very simple. Calculate the real value for A. How will you calculate the real value of A? Remember, A is equals to x plus y minus b. What is x? 100. That's the real value of x, 100. But now I'm not calculating error, I'm calculating A. What is y? 512. What's b? 412. And A will be equal to what? 200. Now, my A now can be written as A, see, my A now can be written as A equal to 200 plus or minus, what's the error in A? 11.3 gram. That's just the way to express A. But this is what the question asks you to calculate. So that's that. So we've gotten the maximum error. So let's go to the standard error. Let's go to the standard error. Now, remember, since I'm having addition and subtraction, so my standard error is something of this form. Delta E square equals to delta x square plus delta y square plus delta b square. So delta E equal square root of delta x square plus delta y square plus delta b all square. So let's go. So my delta A will be equal to square root of, now what is delta x? That's 0.46, that's the error. Okay, now take note of something. If I'm calculating for standard error, so you take this as standard error. If you are calculating for maximum error, you also take this. The question will specify which of them, standard or maximum. And take note of something. If question did not specify whether to use standard error formula or maximum error formula, if the question did not state any of them, take note, you are going to use the standard error. That's the basic one you are going to use. So let's go. This is 0.8 square. This is 10.0 square. And if I stir all this together, so my delta A will be equal to, this will give me 100 points. That will give me 10.04. And remember, my A is 200. So if I want to express my A here now in terms of the maximum error, so my A, instead of the standard error, my A will be what? 200 plus or minus 10.04 grams. So you can see this is for the standard and this for the what? Maximum. You can see the maximum, you have more amount of error. Standard, this amount of error. You can see the difference between them. Now, this is the basic solving. Now, let's go to a challenging question. Now, look at this. We have L equal mr square W. So let me write it down. L equal mr square W, or omega. M is 5.79 plus or minus 0.03 kg. R is 15.19 plus or minus 0.02 meter. And W is what? 21.609, then plus or minus 0.04. Now, this is what we have. Now, the question is this. Calculate L and the percentage relative error in L. Now, that's the question. So, calculate L and percentage relative error in L. Okay? So, the unit of this one is per second. Per second. Now, the question is, how do we calculate L? It's very simple. Calculate L ordinarily means that you want to calculate, I'll not complete the question. And the percentage relative maximum error. That's the full question. Percentage relative maximum error in L. Okay, so we have to calculate L. Let's solve this first one. So let's go. L equal to, what's M? You are calculating L now, the real value, not the error now. You are calculating L. So I'll be using the real value. M is 5.79. R is 15.19 square times W is 21.609. So my L will be equal to 2 points in standard form of 2.89 times 10 is power 4 kilogram meter square per second. So this is the answer for L, and I've gotten that. Now, after getting this, let's go. We are asked to calculate the percentage relative maximum error in L. Now, I have this formula, L equal mr square omega. And we have to calculate the percentage relative maximum error. Forget about those ones. How do we express this L in terms of the maximum error? How do we even find the maximum error in L? So what do we do? Now you can see this formula relates multiplication. So what will I do? The maximum error, you just write the error formula. The maximum error in L over L equal maximum error in M over M plus this one is having a power. Is having a power, you are going to bring down the power to maximum error in R over R plus maximum error in W over W. That's it. So I have EL over L to be equal to, now let's go. What is my EM? What's the error in M you'll be given? That's 0.03 over what's M? 5.79 plus 2 multiplied by, what's the ER? 0.02, that is your error in R, this is it here. Then over 15.19, then plus EW, that will give me 0.004 over 21.609. So my EL over L will give me what? So if I stir this together, it will give me 0.007991. So this is what I have. Now, this is what I have. You see, remember that what is relative error? Relative error, the formula is what? Error over actual value. That's relative error. And this is it, error over actual value. This is relative error. Now, the question now says calculate the percentage relative error. So, percentage relative error is what? Our error over actual value times 100. And altogether, What is your error over actual value? What do you get? Error over actual value is what? 0.0079991 times 100. And what we have here? Multiply this by 100, you have a 0.7999, and that's approximately 0.8%. And that is it. So that is it. Now, if the question now asks you, so this is the answer to the question. But let me now still ask further. If the question asks you to calculate the absolute maximum error, calculate the absolute maximum error in L. What I'm asking to calculate, I'm asking to calculate your EL. What's the value for your EL? How do I get it? It's very simple. Just recall this formula. EL over L equals 0.00799991. Now, I don't know my EL. What is my L? I've calculated L before. I've erased it actually. What did I think I got? 2.89 times 10 raised to power 4 equals 0.00799991. So if I cross multiply, my EL will be equal to 231.19, and that's it. So I have L and I have error in L. So if I want to express L this way, I'll say L will be equal to, what is the real value for L? The real value for L is what? 2.89 times 10 raised to power 4. And what's the error in L? Plus or minus 231.19. And that's my answer. I'll just put the units, which will be like kg m square s minus 1. And that's my final answer. So that's it. The question is very clear. So try to watch over and over again for better understanding. Next question. They said the moment of inertia of the Earth is given by this formula. I equal 2 over 5 mr square. We were giving m to be the magnetic dipole, and this is the unit. So if you see these units in anyone, you know that this is the magnetic dipole. R is the resistance in ohm. If there are maximum error, it means that we are still dealing with maximum error. Here, we are still dealing with maximum error. So just write maximum error formula for all this. Now, caution. Whenever you see a number has no error. For example, I cannot say error in 2 over 2. That doesn't make sense. So take note of that. So I cannot say error in 2 over 2 or error in 5 over 5. No, a number has no error. So it means that whenever I'm writing the formula for maximum error or standard error, I will neglect this number because they have no error. The error is 0. Now, let us just write the maximum error for I. Remember, since this formula is multiplication, the maximum error in I over I equal maximum error in M over M plus, bring this to drop it down, 2 times maximum error in R over R. Okay, so now what's the maximum error in N? Come here, see. Magnetic dipole moment, this is it. And we're told that if there are maximum error of 0.04 in this, so our error here is what? 0.04004 over what is M? 2.145 plus 2 times, what is the error in resistance? This is it. 0.002 over 4.35. So my EI over I, what would that give me? My EI over I, what would that give me? So that should give me, that should be equal to 1.1060 times 10 raised to power minus 2. That is it. So that's my EI. So now the question has said about the percentage relative error in the measurement. You have to calculate the percentage relative error. And what's the relative error? This is it. So it's just like your relative error times 100. So my relative error is 1.1060 times 10 raised to power minus 2, then times 100. So this and this will cancel out, and my answer is 1.1060. So I can just say approximately 1.11%. That is it. Okay, so that's that. So the question has to calculate the absolute maximum error. So what's the absolute maximum error? You're asked to calculate this E. So before you calculate E, calculate I from this formula that you have here. So how will I do that? See, my I is equals to 2 over 5 mr square. M is 2.145. The real value times R is 4.35 then square. So I will be equal to what? So punch your calculator. You're having 16.24 meter square C. Just forget about the unit. I don't. If it's an objective question, forget about the unit. So I've gotten my I. So how will I now get my absolute error? So I'm asked to find this EI. So what will I do? So recall this formula. So EI over 16.24 equal 1.1060 times 10 raised to power minus 2. So if you want to find your EI, what will you do? Cross multiply. You're going to cross multiply this and this. And if I cross multiply, what will I have? So I have 16.24 times this, and my answer will give me 0.18 approximately. So that's the what? Absolute maximum error. So it means that if I want to write my I, the expression for I, the full measurement for I, remember a full measurement must have the value or the magnitude, and the magnitude of I is 16.24. So you have 16.24. That's the value. Also, you must put the uncertainty, and that's your error. And lastly, you must put your what? Your standard of comparison, which is what? C meter square C ohm per second. So this is the final answer. So that's that for that. So let's go to the last question. They said the energy transfer to the molecules of the polyethylene is given by this. If the plus or minus star represent the standard errors, so before we even go further, write the standard error formula for this. So I'll have the standard error in E over E equal to 2. Remember, I'm going to square everything. So here, if I drop down the power, I'll square this standard error, maximum error in standard error in M over M, then also square, plus put the 2 square, maximum standard error in G over G, also square it. Remove your C so you are not using it, but you use pi. Standard error in pi over pi square, plus you can see it can be very rigorous, just endure. Standard error in R over R, you must square it, plus standard error in eta over eta. So I have standard error in E over E square. Now you're going to put all your values. So that will give me 2 square is 4. What's this delta M? That is your error. These are your errors like this. So I have 0.08 over 22.68 square plus 4, 0.02 over 9.85 square plus delta pi 0.001 over 3.142 square. Also, you have 0.005 over 5.936 also square. And what do you have? So you have your N, your eta is 0.003 all over 114.635. So this is what you have square. So if I evaluate all this, delta E over E, so let's see. So delta E over E square. If I punch all this in my calculator carefully, I should be having 6.7070 times 10 raised to power minus 5. So delta E over E, square rooting both sides. If you square root this, I have square root of 6.0070 times 10 raised to power minus 5. And what will be my delta E? So let me put it here. My delta E over E will be equal to 0. So let me write that standard form. That will give me about 8.1896 times 10 raised to power minus 3. So this is what I have. Now, let's now start solving the question. Okay, how do we solve this question? This is it. The question says that we'll calculate the percentage error in the measurement of the energy of the polythene. What is percentage error or percentage relative error? Anyone is what our error over actual value times 100. And what's the error over actual value? You have it here already to be what? 8.1896 times 10 raised to power minus 3. Then times what? 100. So what will you have? You have 8.189 times 10 raised to power. This will give me minus 1. And my answer will approximately give me 0.8189. So my answer is approximately 0.82. Correct. That is it. The percentage error. Put your percent. Nice. So the last thing is the what? Find the absolute error. To find the absolute error, don't forget, we are asked to find this delta E. So we call this formula delta E. We call this formula that delta E over E equal 8.1896 times 10 raised to power minus 3. So remember that to find delta E, you cross multiply. So I have delta E to be equal to E times this. And what is my E? E has been, I've not calculated E. So you have to go and calculate E first. So calculate your E from here. What is E? E equal to M squared G squared. What's the M? Use the real value, 22.68 square, 9.85 square, all over 6 times 3.142 times what's the R? 5.936 times what's the eta? 114.635. So if I point this, E will be what? E will be, what will be this E? E is 3.8904. So that's E. So that's what I'll now use here to multiply this. That's what 3.8904 times 10 raised to power minus 3. And what's the delta E? That's what 0.0. So I have there's a slight mistake here. Okay, this is the mistake here. So what's E? E is 3.8904 times what is, this one is multiplying this. So this E, and I have 8.1896 times 10 raised to power minus 3. So therefore, the absolute error in the measurement of the energy of the polythene is approximately 0.03. So it means that if I now want to write my E, the complete E says what? E equal to, what is the mean value for E? 3.8904 plus or minus 0.03. So that's that for that about the question. So try to like this video, comment on it, share to your friends, and subscribe to this channel. So whenever I release any new video on physical chemistry on all other subject areas included on my channel, you get notified. Don't forget to click the notification bell. Thanks as you do that.